Assalamualaikum. Hi guys. This video is about polarity. We are going to learn how to explain the bond polarity and dipole moment, and the second one, how to deduce the polarity of molecules based on the shapes and their resultant dipole moment. Let's start with polarity. What does it mean by polarity? It is defined as the distribution of electrical charge over the atoms joined by the bonds. So there is a very important thing that you have to know. The first one is how you want to identify two different types of polarity. The first one is bond polarity, where it has two of them, polar bond and non-polar bond. So this is about the bond. Next, we are going to know the different types of polarity based on polarity of a molecule. There are also two of them. First is polar molecule and the second one is non-polar molecule. So kalau lihat dekat sini, beza dia cakap pasal bond polarity and this one cakap pasal molecule polarity. So let's focus with the polar covalent bond dahulu. So polar covalent bond. Apa sebenarnya benda ni? Kita kena faham, bila covalent bond terhasil, sometimes sharing of electrons itu tidak sama, di mana kita ada dua jenis atom, salah satu with higher electronegativity and salah satu lagi lower electronegativity. That is why greater share electrons akan ke arah atom yang mempunyai higher electronegativity, which results a polar bond. So we can conclude that covalent bonds with unequal sharing of electron is known as polar covalent bond. Dan bentuk asymmetry ini result with slight negative and positive charge in different region of the molecule, dan kita panggil dia sebagai partial charge. Bentuk dia macam this one, partial positive, partial negative. As I mentioned before, we talk about polar covalent bond. This is definition for that, which is a bond between two atoms with different electronegativities, where the electron distribution is asymmetrical ataupun tak equal. Dan kita akan relate with the pattern of electronegativity in periodic table. Kita faham the most electronegative element in periodic table is fluorine. So we have to know that the trend for electronegativity akan makin menaik ke arah fluorine. Ini sangat penting untuk kita tentukan polarity. Next, untuk polar covalent bond, there is a specific direction of polarity untuk polar bond, di mana kita gunakan simbol sebagai vector quantity. Vector quantity ni macam mana? Kita akan draw as this symbol, di mana saya ada arrow dan cross n. So cross n ni maksud dia positive n dan arrowhead adalah negative n. For example, saya ada HF. So HF, we can see that two different atoms. So fluorine is more electronegative, kita akan label dia sebagai partial negative. Hydrogen is more electropositive, partial positive. So bila saya nak indicate vector quantity based on this polarity, I will use symbol polarity of polar bond, di mana cross n ni untuk partial positive dan arrowhead adalah untuk partial negative. So that's why awak boleh nampak electron distribution, electron kan negative charge, dia banyak dan besar dekat arah fluorine, because fluorine is more electronegative than hydrogen. Dan kita boleh buat conclusion as HF bond is polar covalent bond, sebab electron distribution tidak sama. Kalau saya gunakan non-polar covalent bond, non-polar covalent bond only exists when there is no difference in electronegativity between two bonding atoms. For example, kita boleh faham bonding electrons tu are shared equally. Contoh macam hydrogen molecule. Kita nampak two hydrogen atoms made up one molecule. So there is no difference in electronegativity between these two hydrogen atoms. That's why we can conclude that HH bond is a non-polar covalent bond. Dia masih lagi covalent bond tapi dia non-polar. As a conclusion, we can summarize that bond polarity is a covalent bond where kalau kita ada polar bond, dia between two different atoms. and then bonding electron attracted to more electronegative atom dan distribution of bonding electron itu tidak sama. Contoh dia macam HF. Next, kita ada non-polar covalent bond between two identical atoms and bonding electrons are distributed symmetrically between two similar atoms dan dia share equally. Contoh dia macam hydrogen molecule. Next one. Bila kita sudah faham tentang bond polarity, kita akan masuk bahagian dipole moment. Simbol dipole moment adalah mu. Ini adalah simbol dia. So, we call it as mu. So, mu ni apa? Kita kena faham dulu. When we want to separate the charge in polar covalent bond, kita ada partial positive dengan partial negative. Nak separate charge tu kita call the process as polarization. Dan untuk determine the value for that polarization, kita akan gunakan quantitative measure of molecular polarity, iaitu dipole moment. So, dipole moment is defined as hasil darab magnitude of dipole. Dipole moment ada specific formula daripada this definition, iaitu mu equals to Q times R. So, di mana R ni adalah distance between charge dan Q adalah charge in coulomb. For your matriculation level, you don't have to calculate the value for mu. You just only should understand whether mu equals to 0 or not sahaja. You don't have to calculate. But at least I hope you can understand the different charges can be separated via polarization. Kita sambung lagi bahagian dipole moment, di mana dipole moment usually measure in dBs, D, capital D. Dan kita nampak dia ada formula yang spesifik in previous slide, and 1D ada value yang spesifik. Kita boleh lihat kat sini, if mu is high, the molecule is said to have high polarity. So, to conclude that, awak tak perlu calculate, but you have to understand, sekiranya mu is not equals to 0, we can understand the molecule is polar. But if mu equals to 0, the molecule is non-polar. So, dia opposite. So, ini sahaja yang awak perlu faham untuk dipole moment. Next, we go for polarity of a molecule. Molecule with non-polar covalent bond usually will be a non-polar molecule. So, kita tak perlu decide lah this one, dia memang fix. Dalam kes ini, bila molekul tu ada non-polar covalent bond, memang dia akan jadi non-polar molecule. For example, saya ada Cl2. So, there is no difference in electronegativity between two chlorine atoms. So, kita boleh conclude Cl bond dekat sini is non-polar covalent bond. Therefore, Cl2 is non-polar molecule. So, ingatlah these tips. Bila ada molekul tu mempunyai non-polar bond, automatically that molecule is non-polar molecule. Sekarang kita nak tentukan polarity for the molecule. Contohnya molekul yang mempunyai polar bonds, di mana dia mempunyai 2 atau lebih atoms, that molecule boleh jadi polar ataupun non-polar molecule. So, kita kena lihat satu persatu, dan polarity for polyatomic molecules depends on overall dipole moment, ataupun istilah yang kita akan guna selepas ni adalah resultant dipole moment. So, the resultant dipole moment ni adalah hasil tambah dia punya bond dipole, di mana setiap bond dalam molekul tersebut kita kena indicate menggunakan simbol dipole moment, iaitu this one. So, saya akan explain berdasarkan these two examples. Kita nak tentukan polarity based on overall dipole moment ataupun resultant dipole moment for that molecule. For example, saya ada HCl. We can understand that Cl is more electronegative than hydrogen. That's why kita akan letak partial negative on Cl, partial positive on hydrogen. Then, we can indicate the symbol for dipole moment is towards chlorine, because chlorine is more electronegative. So, bila dia hanya ada satu saja direction, kita boleh faham mu is not equals to 0. Then, apa point yang kita kena letak dekat sini? We talk about this bond first. So, this bond, HCl bond, is a polar bond. However, because of dipole moment is not equals to 0, kita boleh conclude that HCl is polar molecule. Now we go for the second example. Saya ada CO2. CO2, we can understand that carbon is more electropositive than oxygen. So saya akan letak partial charge untuk carbon dan oxygen. Then, saya boleh label direction dipole moment saya towards oxygen sebab oxygen is more electronegative. So bila kita ada two directions opposite to one another, kita boleh nampak dia static dekat situ. That's why these two directions can cancel out each other. Bila dia cancel out each other, so dipole moment dia equals to 0. Cakap pasal polar bond dahulu, so bond yang kita ada adalah antara C double bond O. Kiri atau kanan sama sahaja. Kita boleh conclude that C double bond O bond is a polar bond. However, because of dipole moment is equals to 0, CO2 is a non-polar molecule. Now we go for the step how you want to determine the polarity of molecule. As I mentioned before, molecules with polar covalent bond can be either polar or non-polar molecule. So this is how we are going to determine step by step, but the first thing first, you have to know how to draw the shape of that molecule. So to draw the shape of the molecule ataupun the molecular geometry for that molecule, you have to draw the Lewis structure first. After that, baru awak boleh tentukan molecular geometry dan describe electronegativity between atoms in the molecule and tentukan dipole moment based on the bond polarity, and you can determine the molecule arrangement based on molecular geometry. So macam mana molecule arrangement ni? Maknanya cara dia disusun. So ini daripada step 5. Kita akan tengok bahagian molecular geometry, di mana molecular geometry ada dua cara disusun. Yang pertama in symmetrical shape and yang kedua adalah asymmetrical shape. Kita fokus dahulu asymmetrical shape. Asymmetrical shape maknanya dia tidak susun secara simetri. That is why bond dipole cannot cancel out each other. Hence, dipole moment is not equals to 0. The molecule is polar. Kalau kita ada symmetrical shape for the molecule, contohnya macam linear, trigonal planar. So kalau nampak, ini semua adalah basic shape. So basic shape is one of the symmetrical shapes. Termasuklah square planar. Sebab square planar dia ada dua lone pair, hanya ada 4 bonding pair. So dia boleh cancel out juga. So bila kita dah tahu dia dalam bentuk symmetrical shape, kita kena lihat juga dalam symmetrical shape tersebut, kita kena lihat terminal atoms. Kalau identical terminal atoms, kita boleh conclude dia adalah non-polar molecule sebab dipole moment is equals to 0. Sekiranya dia adalah non-identical terminal atoms, the molecule is polar because dipole moment is not equals to 0. So, banyak kan benda ni yang kita perlu tahu. Apa kata kita try a few examples so that awak akan nampak contoh dan cara jawab how to determine the polarity of a molecule. Let's try example 15. Example 15, we have HCl. So, macam mana HCl? Kita lukis dulu Lewis structure dan deduce dia punya molecular geometry. So, saya akan lukis terus molecular geometry for HCl, di mana HCl bentuk dia straight sahaja. So, awak akan dapat like this, H bonded to Cl dan Cl ada 3 lone pair. So from here, awak boleh nampak chlorine is more electronegative than hydrogen. That is why saya akan label partial negative on chlorine and partial positive on hydrogen. And then kita boleh indicate that HCl bond here is polar covalent bond because there is difference in electronegativity between H and chlorine atom. That is why saya boleh indicate the direction of dipole moment to chlorine. So ini direction dipole moment saya. Kita boleh faham sekarang dipole moment is not equals to 0. Therefore, my conclusion HCl is a polar molecule. So itu cara nak jawab. Next we go for example 16. I have CO2. So CO2, you draw the Lewis structure and determine the molecular geometry. Saya boleh nampak CO2 is a linear. So ini Lewis structure dia. So if you take a look here, your terminal atom is oxygen, central atom is carbon. So oxygen is more electronegative than carbon. That is why saya akan label carbon electropositive, oxygen electronegative, both terminal atoms. I can identify that C double bond O bond in CO2 is polar covalent bond because you can see that difference in electronegativity, ada partial positive, partial negative. Next, awak kena tambah satu benda iaitu tentang bond dipole awak. So kalau lihat bond dipole awak adalah equal in magnitude, di mana awak punya direction of dipole moment from carbon to oxygen untuk one side and another side carbon to oxygen another side. So awak nampak dia ada opposite side untuk both direction of dipole moment, maknanya dia equal in magnitude dan symmetrically arranged dalam bentuk linear. Hence, kita boleh anggap these two direction of dipole moment can cancel out each other. Itu point seterusnya. Hence, the overall dipole moment is equals to 0. Therefore, CO2 is non-polar molecule. So, ini cara kita jawab for CO2. Now, we go for CCl4. CCl4, first, draw the Lewis structure and then deduce the molecular geometry for CCl4. We can understand it is tetrahedral. So, kalau korang nampak dekat sini, central atom is carbon and you got 4 same terminal atoms which is chlorine. And chlorine is more electronegative than carbon. Hence, saya boleh letak partial charge dekat sini for chlorine is partial negative untuk each chlorine. And then untuk carbon partial positive. Next, kita boleh faham dekat sini due to difference in electronegativity between carbon and chlorine. So this bond, CCl bond in CCl4 is polar covalent bond. And then, kita boleh lihat bond dipoles untuk each CCl bond are equal in magnitude dan symmetrically arranged dalam bentuk tetrahedral. So, tetrahedral dalam bentuk case ini adalah basic shape. Hence, kita boleh lukis direction for dipole moment. Awak kena draw dipole moment direction for each bond. So, saya ada 4 bond dekat sini. So, saya akan draw each of them towards chlorine. So, awak akan nampak like this one. Kena draw satu persatu. Kita boleh anggap dekat sini, bond dipole can cancel out each other. So, kalau lihat dekat sini, yang ini akan cancel yang ini akan cancel yang ini. So, that's why bond dipole can cancel out each other. The dipole moment is mu equals to 0. Therefore, we can conclude that CCl4 is non-polar molecule. Let's try the next one. We have CHCl3. So CHCl3, draw the Lewis structure and determine the molecular geometry. You will have like this. This is the shape for CHCl3. If you take a look here, you got different terminal atoms. Awak ada 3 chlorine atoms dan awak ada 1 hydrogen atom. So, kita akan indicate electronegativity between different atom tersebut. So, first, electronegativity for chlorine is greater than carbon. And the next one, electronegativity for carbon is greater than hydrogen. Hence, dalam kes ini, kita boleh conclude that CCl bond yang ini ada 3 CCl bond and CH bond ada satu dekat sini in this molecule is polar covalent bond sebab kita boleh nampak ada difference of electronegativity between them. Next, bond dipole. Dalam kes ini kita nak draw the direction of dipole moment. Untuk CH bond dia akan move towards carbon like this. However, untuk CCl bond dia akan go towards chlorine. And then awak akan dapat this one. Ingat, kita kena label satu persatu untuk each bond. Then you can see that the bond dipoles are not equal in magnitude. Sebab satu ni ke bawah, yang ini pun ke bawah. Dia tak sama. Patutnya this one ke atas. Tapi sebab ini adalah hydrogen, dia turun ke bawah. tapi bentuk dia masih lagi symmetry, iaitu tetrahedral shape. Hence, kita boleh nampak dekat sini ada resultant dipole moment kerana semua dipole moment menuju ke arah bawah. Kita akan ada resultant dipole moment like this one ke arah bawah juga. So this is my resultant dipole moment. As I mentioned before, apa tu resultant dipole moment? Dia adalah hasil tambah semua bond dipole dalam molekul ni. Kita ada 4 bond dipole yang ke arah bawah. So kita akan lukis resultant dipole moment dekat tepi untuk indicate hasil tambah semua bond dipole. So you can understand that bond dipole ni cannot cancel out each other sebab magnitude dia tidak sama. Hence, resultant dipole moment mu is not equals to 0. So a bit different from previous examples. Example this one kena tambah perkataan resultant. And therefore, kita boleh conclude that CHCl3 is a polar molecule. Let's try one last example. I have H2O. Kalau lihat dekat sini, H2O, the molecular geometry for H2O is V-shape, like this one. So you can understand here, oxygen is more electronegative than hydrogen. That is why untuk bond polarity kita akan ada partial negative on oxygen and partial positive on hydrogen. And then kita boleh anggap this bond, OH bond, is polar covalent bond because different partial charge. Next, kita boleh lukis sekarang the direction of bond dipole ke arah oksigen. So, both of them towards oxygen. So, dia dalam magnitude yang sama. Equal in magnitude for the bond dipole. But the shape is not symmetrical because this shape for molecule of water is band ataupun V-shape. That's why kita boleh nampak kerana bond dipole kedua-duanya bertumpu ke arah oksigen, maknanya dia ada resultant dipole moment ke arah atas. So ini adalah saya punya hasil tambah semua dipole moment dalam H2O molecule. Hence, kita boleh nampak resultant dipole moment towards one direction only, so the bond dipole cannot cancel out each other. The resultant dipole moment mu is not equals to 0. So bila mu is not equals to 0, therefore we can conclude H2O is a polar molecule. Kalau baca lebih sikit kan, awak akan perasan ada satu statement about H2O is a polar solvent. So you can relate lah dengan that statement. So I hope you can finish try this 4.0, 5.0 and 6.0 about polarity. Try to apply everything and I hope you can practice more and more so that you can enhance your understanding. Thanks for watching. Bye.